All right, welcome back to the deep dive. So today we're going to dig into something that, sounds a bit niche, but is actually a huge deal in the real world.
It really is.
We're looking at how you get high-def video over massive distances using standard, cheap network cables. Specifically, we're tearing down the specs of a device like the NTI HDMI over IP extender.
And our mission here really is to demystify this whole AV over IP world for you. I mean, this tech completely changes the game for huge installations, think airports, university campuses, that kind of thing.
Right.
It lets a simple network cable do a job that used to require these incredibly expensive custom AV systems.
Yeah.
It's a real game changer.
Okay, so let's just break this down. A normal HDMI cable, it sort of dies out after, what, 50 feet maybe?
If you're lucky, yeah.
So what kind of range are we actually talking about when you convert it to run over a network?
This is where it gets impressive. You're basically turning your entire network into one giant HDMI cable. We're talking up to 394 feet, that's 120 meters, if you're using good quality Candy 6 or Candy 7 cable.
Yeah.
And even with standard CTT5e, you're still getting around 328 feet. And this is all just over a standard Gigabit Ethernet connection.
So to push that much data, it has to be compressing the video, right? I was reading it uses H.264.
It does, yeah.
And the spec sheet claims a latency of under 100 milliseconds. I mean, is that actually fast enough? Is that something you'd ever notice?
That's a great question. For what this is built for, digital signs, broadcast monitors, menu boards, no. You will never see a 100 millisecond delay. It's virtually instant to the human eye.
Okay, so it feels real time.
It does. And it's also built for professional use, so it supports HDCP 1.4.
Ah, the digital handshake.
Exactly. That's the thing that prevents you from getting that dreaded black screen when you plug in, say, a Blu-ray player or another licensed source.
Got it. Okay, so distance is solved. That's huge. But what about scale? Is this just a one-to-one cable replacement, or can you build something bigger?
Well, it starts that simple. You can do a point-to-point connection, which is literally one transmitter box connected to one receiver box with a network cable.
Super simple.
But the real power, of course, comes when you introduce a network switch. Then you can do point-to-many.
So one video source to how many screens?
With a simple, unmanaged switch, the kind you can buy anywhere, you can send one video source to as many as 253 different screens. But, and this is a big but,
There's always a catch.
there is. With that simple setup, you can only have one transmitter, one video source on that entire network.
Okay, hold on. Why is that? What's the technical bottleneck that limits you to just one source on a simple switch?
It all comes down to traffic. These video streams they are massive data floods. On an unmanaged switch, every packet from every source goes everywhere.
A broadcast storm.
Exactly. If you put two or more of those video floods onto the same simple network, they just collide and overwhelm the switch. Performance for everything grinds to a halt.
Right, it would kill your main office network if it was shared.
You would absolutely destroy it.
Yes.
So if you have multiple sources, say a news feed, a marketing video, and a live camera feed, you have to get smarter.
And that means stepping up to a managed switch.
Precisely. To handle multiple transmitters, you must use a managed switch that supports something called VLANs.
Virtual local area networks.
Right. And you can think of a VLAN as creating a separate, private digital highway inside your network that's dedicated to just one video channel. It isolates the traffic completely.
So each video source gets its own private lane.
One transmitter per VLAN. That's the key. It's how you scale the system without everything crashing into each other.
And that's pretty clever because I saw the system as plug and play. So the receivers just automatically find their transmitter as long as you've set up that virtual highway for them correctly.
That's the magic of it. It takes this huge, complex AV problem and just turns it into a standard IT networking task.
Which is much more manageable for most places.
Way more. But if we connect this to the bigger picture, it all circles back to the network hardware. The total number of sources and screens you can run ultimately depends on the backplane bandwidth of that core switch.
The total traffic it can handle.
Yes. And that raises a really important question we want to leave you with to think about. How might the hard bandwidth limits of your switch force you to change your design plan for, say, a massive multi-source video wall? Would you have to lower the resolution or maybe refresh the content less often just to make it all fit?